Bismillahir Rahmanir Rahim. So, dear students, so today we'll be having the topic that is Saytzeff versus Hofmann elimination reaction. It's a very important concept and a very important topic in the organic chemistry. So, to the point, I will go first. What actually Saytzeff's rule means? What is Saytzeff's elimination? So, basically, this is an empirical rule. And what is its importance? It's important that it helps us in predicting the major product obtained in any elimination reaction. So if you have any elimination reaction, after the elimination of the atoms or groups, we'll get the products. We'll get two types of products. Now, which is the major one? That is predicted with the help of this Saytzeff's rule. To understand this, let's go to this reaction. Now, this is an organic compound. Let me first name this. This is 2 carbon. This is 3 carbon and this is carbon number 4. So at 2 position we have iodine. So this is 2-iodobutane. Now 2-iodobutane, when it is treated with potassium hydroxide, so what happens? It undergoes dehydrohalogenation. So halogen will leave from here. Fine. Now this carbon will get a positive charge. Now this positive charge can be stabilized by hydrogen, by the removal of hydrogen from this carbon or removal of hydrogen from this carbon. So now there are two possibilities. If this hydrogen gets removed, this hydrogen, so we'll get a double bond here. So the product formed is this one. And in the other way, if this hydrogen gets removed, this one, then double bond comes here. So you have, this is the major, this is the product formed. So which is the major product formed? Whose concentration is more? So it simply depends on that where the double bond is more substituted. Now if you look at these two compounds, this double bond, it is more substituted because on this carbon you have a methyl group here, alkyl group and hydrogen atom. On this carbon you have alkyl group and you should say methyl group and hydrogen atom. While as if you look at this double bond, you have an alkyl group here, hydrogen, and this side also you have 2 hydrogen atoms. So you have on both the carbons 2 alkyl groups here, so this is more substituted alkene. So this is the major product. And remember this, more substituted product is formed in the major concentration and this is considered to be thermodynamically most stable product. So this is the Saytzeff's rule that in any elimination reaction, for example dehydrohalogenation of alkyl halide in presence of base, the major product formed is the one which is more substituted. So similar type of reaction is another one, that is the Hofmann elimination. Now this elimination most importantly we see in the alkyl ammonium salts. So alkyl ammonium salts, they undergo the the removal of groups, elimination of the groups to form a double bond. Which is more substituted? Now as per the elimination of after the Hofmann's rule, the one which is least substituted is the major product. Let's talk about this example. Now this is our amine compound. If you treat this amine compound with methyl halide, now simply this CH3 will come because we have lone pair here. So this group, in one step one of the hydrogen will get replaced by CH3. Then the next step another hydrogen will get replaced by CH3. And in the final step we have this compound formed. So this we have seen in our previous topics. Now from here we'll apply the rule. If you heat this compound in presence of silver oxide, what happens? This group gets removed. If this group gets removed, so what happens? A positive charge comes here. Now we can use the same concept. We have hydrogen atom at this carbon, hydrogen atom at this carbon. So if this hydrogen atom gets removed, this one, then you have a double bond here. And if this hydrogen atom gets removed, then you have a double bond here. So this is the compound formed, this and this. Now the concept is that which is the major amount formed? As per the Hofmann rule, this is the major product formed. Now you can clearly see, we know this is less substituted, this is more substituted. So as per Hofmann elimination, less substituted product is formed in the major amount, while as in the Saytzeff's rule, the more substituted product is formed in the major amount. Now the question is that why it is here reverse? If thermodynamically more substituted is the stable, then why this is formed? Now we can read this line here. So the least substituted alkene is favored due to unfavorable steric interaction. Now in this case, this has to get removed and then proton will be removed from the base. If the base approaches from this side, then that base has to, has to face the steric interaction of this bulkier group. So it's easy for the base to come from this area, and then it gets removed from here. So if it comes from this area, that base will face the steric repulsion, a steric interaction of this quaternary ammonium group. So that's why it gets eliminated from this side, because steric interaction is less. So in case of quaternary ammonium salts, when you heat them with the silver oxide, you will get the least substituted product in the major amount. So this is all what we have from the Saytzeff's rule and Hofmann's rule. Now again, I will just quickly wrap it up. So Saytzeff's rule says that in the dehydrohalogenation, in the the elimination reaction, particularly for example where the halogen gets removed in presence of base, the major product is the more substituted as per the thermodynamics. But in case of Hofmann elimination, the product formed is the least substituted. So this actually works as per the steric interaction. So this is all what we have.